Hello, hi everyone. So this is the new series which I am going to start, and this is basically the series on journey to become a Salesforce architect. I have been getting a lot of requests or a lot of comments to make a series of this, and I've been thinking of it. So what I'll do is I'll basically create a few videos in this series, and in each video I'll pick up one topic on how to become a Salesforce architect, the journey to becoming a Salesforce architect. I'm going to pick one topic in each video of this series. So it is going to be a series of multiple videos, and I'm going to talk more about that in each of those videos. So the first thing, or the first video in this series, is basically about, first of all, what we need to do is understand the mindset, right? And today we are going to talk about the mindset of an architect. So I would say, more than the skills, it's about the mindset which is important. So the moment you have the mindset of an architect, the moment you start thinking like an architect instead of thinking like a junior resource or a developer, 40 to 50% of your journey is already over. So the first and the most important thing is building that mindset, bringing in that perspective. How do you think? What are the points that you think when you are working on a project? That is very, very important, and that is the key also to becoming an architect. So first, to become an architect, first of all, start thinking like an architect. So the mindset shift, which is very important, as I said, start thinking like an architect is going to be the key here. All right. Now, how do we, or what is the key difference, or how does an architect think as compared to a usual developer or a senior developer or a tech lead? So where are the differences, or what different perspective an architect brings? So let's quickly understand. There are a lot of things. I may not be able to talk about everything, but I have captured a few points here, and I'll basically want, or I would rather encourage you to start thinking in that direction. Starting today, if you really are aspiring to become an architect, start thinking in those directions, start thinking in those lines. So I have tried to do a comparison of how a developer would think versus how an architect would think. The mindset of a developer versus the mindset of an architect. So developer usually thinks about building a feature. So developer mindset is usually, how do I build a feature, versus, yeah. So developer would think about build a feature, whereas architect mindset would be about building frameworks rather than features. Of course, features are important, but do we randomly keep on building the features, or do we need some sort of a framework so that whenever this feature that we are building, if this scales up at a later point of time, will the future development requirements or enhancement requirements fit into that particular framework, right? So instead of building small features randomly, architect mindset would be to think of a framework where this requirement, the current requirement plus the future requirements are also considered at some point of time, right? Developer mindset usually would be, how do we build this? So there is a requirement in front of the developer, and developer usually thinks, how do I build this particular requirement? Whereas an architect would think in a slightly different way. The first question that an architect would have, and I'm talking about this from my personal experience, when I get a requirement, I usually ask, do we even need this? And it's not a question that you have to ask someone in the team or from a business stakeholder. But first of all, this is a question that you need to ask yourself. Look at the overall system, architecture, design, how it is built, and then try and understand, is this even required? Is there a better way of achieving the same thing? So usually, and again, I'm talking from my personal experience. On a lot of projects, I have seen business requirements which come to the dev team or to the architects discussion board, etc. A lot of those business requirements are, business would say that I want you to build this, but a lot of times those are not even required to be built. The reason for that, it is not that what business needs is not relevant or not important. It is about, and this is where the confusion is, right? So it is about the same feature or a better feature or functionality is available already somewhere else. Business is asking you for something because they are possibly not aware of what is already available, right? So it's something similar to that, right? So business may not be completely aware of certain things, and they will then start thinking of different ways of achieving it. And as an architect, if you have a holistic view of the application, which of course you do not expect the business stakeholders to have, then you will end up building everything. So the mindset of an architect is not just go straight away and build this, whatever is required or whatever has been requested. The question that architect usually asks himself, or tries to validate it against the system, or even ask the business, do you really need this feature? Okay, so of course there has to be a discussion that ways also. I remember in one of our recent implementation, business wanted some 8 to 9 custom fields to be created on account object for some reporting purpose. All right, now what we realized that in the data model, it was possible. I'll not go to get into the details, but I would say that it was possible to derive all those 8-9 information of those 8-9 fields that they needed, the KPIs that they needed for report, from a related object of the account, and it was not required to have all those fields created in that particular object. Now, as a business stakeholder, possibly they were not completely aware of how the data model works, what are the reporting capabilities that Salesforce has the ability to basically do reporting on the related objects, etc. And that is where they may have thought that it is required for them to have, because they do not know, how do the relationships, etc. work in the report. So they raised a requirement, or they basically gave a requirement that we need these additional 8 or 9 custom fields to be created on account. The moment we started looking into the overall data model, we realized that it's not even required, right? So that is the thing. Third important thing is the visibility of a developer. So this is very, very important. And this is something which I would recommend every developer. Usually as a developer, and I have been a developer myself, so I also understand this. When you're a developer, your visibility or the scope of what you are looking at is usually the user story that you're working on, maybe sprint. Okay, how many user stories are assigned to you? How will you finish that user story? Stuff like that, right? However, as an architect, the visibility is usually the overall project scope and not just that user story or sprint. Now, this is very important. Why this is important? Because if we are just confining ourselves to thinking about one user story, one feature, one sprint, then we really don't have the visibility on the entire project. And if we do not have the visibility on the entire project, of course, we are not thinking like an architect. The next and very critical point is, usually as a developer, the focus is always on the current user story, current work assigned to me. Whereas for an architect, the focus remains on the future system. What sort of system are we building? Will this system be able to scale up, if there is more code added to this, if there is more data added to this, if there are more users using the system, will this system still work? So that is the difference between how a developer thinks versus how an architect thinks. Now, the next important thing is the mindset, the key questions, right? The common questions. So basically, if you start building your mindset like an architect, so there are a few common questions that you can start asking yourself from now. So how do you do this mindset shift? Start asking some very common questions. There are a lot more, but I have tried to list down few. So start asking these questions to yourself. Then start asking these questions to someone who is possibly, let's say if you're not the architect on the project, if there is someone else who is playing the role of an architect, try to ask that question to them. Try to ask those questions to yourself. Try to validate all these things. Like, should we even build this? So I spoke about this already, that every feature which comes as a requirement is not always required to be built. The question is not about whether you need this feature or not. If there is a requirement, it is a valid requirement. Okay, but the reason for this question is there a better way to get this with lesser burden on the system? All right, what happens when data grows 10 times? So what would happen to this system if the data overall grows? What would happen to this system if the overall code base grows? What is the failure strategy? Do we have a failure strategy in place? So if whatever I am building, if that doesn't work properly, if things fail, what is the failure strategy? What are my plan to handle some exceptions, errors, etc. So that is the thing. What is the integration impact? So if I'm building something, will it have an impact on the other systems where we are basically other systems that we are connected with? So as an architect, you only do not think about the Salesforce implementation. You also take into consideration the other systems which are interacting with your Salesforce. What is the security implication? So this is another important aspect. So just straight away, don't go and start building something. You'll have to think about it that, okay, will this, whatever we are building, will it have a security implication? If yes, how do we control that? What is our plan to minimize the security related concerns, etc., right? What is the cost of the decision? So if every time we think of something, whatever we are building, there's a cost associated to that. That cost can be in terms of the time and effort that goes into it. The cost can be in terms of money which goes into it, in terms of, say, licensing fee, etc. So if you decide to use a certain type of a license, then there will be a recurring cost in terms of the license, etc. So what is the cost of this decision? So whatever decision we take, what sort of impact it will have versus what cost it will have, etc. Will we hit the governor limits? So with the approach that we are taking, is there a possibility that we'll end up hitting a governor limit, etc.? So if that is going to happen, then of course we have to think of different ways, or we'll have to think of how do we handle those governor limits, or how do we optimize our solution to ensure that we are able to execute the logics without hitting the governor limits, etc. How do we reduce the technical debt, which is very, very important? Most of the projects struggle with a lot of technical debt which is there. And how or what is the most feasible way to reduce that technical debt? What frameworks should we use? It should be used, right? So are there specific frameworks which can be used, etc.? So that is another important thing that we have to work with. Key skills or key areas where there are 5 important areas where you should be thinking as an architect. So and these are your scalability is one, reusability, maintainability, security, and performance, right? So these are the 5 key areas where you have to start focusing on. So scalability perspective, try and understand whether your system, whatever you are building, is it ready for exponential growth? Because any system will, so whatever you are seeing in the system right now, or whatever you are building, over a period of time, the system will grow. It will grow in terms of data, it will grow in terms of code logics, it will grow in terms of number of users coming in, the use of the code that you have written, it will be used by more people. So don't build something based on what you see right now. Try and understand how things are going to grow. When usually I get into these discussions with any client on a new implementation, I try to understand things not just about how many users, what is the inflow of data. I also try to understand that how things are growing and what is the expected growth rate, right? So those factors are very, very important, because any system will not be used the way it is being built today. Over a period of time, it will grow, right? And it will grow in terms of everything, as I said. So it's very important for an architect to build a solution which is ready to handle those exponential growth. Then another important thing is your system should be large data volume ready. So what is your plan to work with large data volumes in case if there is large data that needs to be handled, which is very important topic again, as part of your journey as an architect, understanding large data volumes, understanding how to deal with the large data, etc. How to optimize your solutions. What are the options available in Salesforce? Because Salesforce, of course, is not the best platform to store huge amount of data, millions and all that records. It is not built that way. It is a on-cloud solution, and it prefers to stay light, right? However, so having said that, this is also true that as business, you may want to do reporting on large data volumes, etc. So there are a lot of options available within Salesforce to work with that. And I'll be doing a complete different, I would say, one different video completely dedicated to this large data volume, because it's a big topic. Your query selectivity and indexing approach, how do you make your queries run better, faster, and enhance the performance of your queries, etc. Asynchronous processing strategy, so how and how are you planning for your asynchronous processing? So first of all, there will be a difference between when to use synchronous versus when to use asynchronous. Within asynchronous also, because if you over a period of time, if you have a lot of asynchronous logics, you'll have to also plan for the strategy for your asynchronous processing as well. You cannot be pushing everything to asynchronous without a plan or without a strategy. Of course, whatever is not synchronous should be pushed to run as asynchronous, but at the same time we have to understand that asynchronously also, when you're running certain things, long running operations, over a period of time, when you have a lot of asynchronous code, you need to have a proper strategy for it, right? Then data archival and lifecycle planning. So another important thing is you have to have a plan for, as I said, Salesforce always is not the best place where you just keep on dumping all the data. It's not meant for that, right? It is a system which is meant to store relevant data which is being used by the users, etc. So historic data, etc., ideally is not very much recommended to be stored in Salesforce. So if there is something which is completely not being used by your users, it is better to plan for an archival strategy or something like that, okay, depending on your requirement. Do you just need that data for reporting? Then there are different options for that. And if you just need that data for some compliance audit or whatever reason, right, then you need to plan on how will you archive the data time to time, so how frequently, and what will be your archival plan, etc. So those things need to be then planned. The next important aspect here is, of course, the performance part of it. Now in performance would mean everything. In performance can be how quickly my so-called queries get executed, how quickly my users are able to load the pages, how quickly the users are able to get response, how quickly my Salesforce is able to interact with another system. Everything will be associated to performance. And of course, with Salesforce, Salesforce being an on-cloud CRM, performance is of course meant to be one of the key things for any of this applications, right? So your efficient data access patterns, so accessing data needs to have efficient patterns. Governor limits driven design. So the design should be in such a way that your design considers governor limits. Salesforce has governor limits around everything. So your design should consider governor limits, and then it should be designed, or your system should be designed in such a way so that they do not hit governor limits frequently. Synchronous versus asynchronous decision. So this is another important thing. A lot of synchronous, even if you start looking at your current organization or current implementation, you would see that there are a lot of synchronous logics, a lot of triggers which can be possibly transferred to asynchronous epics, all right? And that is something which a lot of times we miss. So we get a requirement, we instantly think of putting it as a trigger or something like that, right? So that those execution decisions are important. Bulk first processing approach, so try to bulkify things, and all that is going to reduce the number of transactions, etc., that you make. And user response time optimization. So these are basically the key things that you would need to consider or think about from a performance perspective. The next one is, of course, the reusability. Reusability is another very important thing. So reusability helps in two ways. So one, it helps in reducing the build time. Rather than building the same thing again and again and again, it helps save time in terms of development. And secondly, it also helps in maintaining clean clean code or clean overall development components that you have, right? So try to work with modular and generic design, which can be reused at different places. Try to build shared utilities. So try to build a utility if there is a utility which is going to be used by multiple objects. So try to see what is the best way. As I said, try to build modular design so that the same utility can be used by different objects. Maybe try working with configurable things instead of hard coded logic, right? I can give you an example. Think of it. Let's say if you're creating a logic with, say, you're building an algorithm with 4 types of let's say you're basically trying to build a logic around incentives, okay? And there are 4 categories of incentive that the sales reps would get, and you are required to build an algorithm around that. Okay, so now while you're building this logic, just don't think about this, that okay fine, I'll have to build it around those 4 categories. In future, the company may want to reduce that to 3 categories, or the company may want to increase that to 8 categories, right? So when that happens, at that point of time, it should not be like a roadblock, or it should not be a complete code change, etc. So instead of hard coding the logics, try to see if there is a configurable way, easy way to make tweaks into the logic without actually getting into the code, without actually doing the entire cycle one more time. Try to build reusable components which can be reused in different places, and avoidance of duplicate logic. So try and avoid duplicate logics as much as possible, or you should not have duplicate logic. So you should try to use whatever you have built earlier and reuse those things, right? The next one is the maintainability. Now maintainability is where again it's an important thing. So what we are building today, we have to also understand that how will we maintain it over a period of time? Will it become difficult for me to maintain it? So that is an important thing. So think from that perspective. So from a maintainability perspective, it is very important that not just me, but if someone else who is new starts looking into the code, is able to understand, is able to maintain with minimal effort. All right. So clear separation of concerns is very important. Logics overlapping and very tightly coupled logics across classes or components, etc., will only make life difficult in terms of maintaining that particular application, right? Then readable and consistent code structure. Now this is very important, and this is highly underrated, I feel. A lot of times you would see that different classes have got different structure of code, right? Because they were of course built by different developers. So it is a very good practice to define some best practices, patterns, etc., and everyone in that team starts following that, so that the overall code structure, the overall, and those can be basic things as well. Like for example, if I say something as basic as, before you create a method, just define a comment of what that method does, right? That can make things so simple for anyone who is actually coming back and looking into the code of that particular method, rather than reading the entire method and trying to understand if there is a comment on top of the method on what exactly this method is doing. Simplifies life for everyone, right? So your consistent code structure, readability is very important. Loose coupling between components is very important. Again, as I said, do not have too many components which have got overlapping logics, etc., and it will end you will end up making huge changes for a small change in one of the components, etc. Testability and automated testing should be, of course, one of the key factors in terms of maintainability. So time to time, there should be enough room or scope for testing the components or the logics independently, and ease of future enhancement. So anything should be built in such a way so that in case there are more enhancement to be added, it should be easy to add more enhancements. Now the next one is security, which is again very, very important and needs to be considered as one of the highest priority items. So one most important thing that we always speak or we always think about is the least privilege access model. What does it mean? Anyone should have the least access which he requires to perform his day-to-day task. So I should not have even one additional permission or access in addition to what I actually need to perform my task. So this is called least privilege access model. This is very important. So the entire access control should be designed in such a way. It should not be like, okay, fine, let me give everyone access to everything, whoever needs whatever they will get. That should not be the approach. So it should be, if there is a user, he should have the least privilege to perform his day-to-day task. What is the minimum privilege or access he would require to perform his day-to-day task? He should not have limited access that is not letting him perform his task. So he should be able to do his day-to-day task, but minimum access which is required, right? Nothing more than that. Data visibility and sharing strategy is very, very important. So, while we are talking about the overall access in terms of say objects, fields, pages, etc., code, visibility of data and sharing is equally important or even more important, because you really need to control who gets to see which data, etc., and you completely need to control that particular section. I'm going to do a complete video in this series, I'm also going to do a complete video on visibility and sharing, and I'll say possibly I may require 2 videos also for that. A secure integration design is important. So if your system is interacting with other systems, then it is very, very important for you to ensure that your system integration is working securely, right? Compliance and audit readiness is very important. A lot of places, and I think most of the companies do have their own internal compliance requirements and audit requirements, etc. So that's very important. And the next one is protection against misuse and abuse. So it needs to be designed in such a way so that the system cannot be misused or abused in any way. Having said that, having spoken about all these areas, I would quickly want to talk about 5 key skills that everyone or each architect usually needs to master, right? What are those 5 key skills? First is data modeling. Now, data modeling is highly underrated again. Uh, uh, as an architect, I feel that the first thing that you need to have is a very solid understanding of the entire data model. Which objects, what relationships, how are they related, etc. I see a lot of people lack here, right? They keep on using, so usual account, contact, opportunity, this data model is clear to most of the people. Beyond this, sometimes a lot of people have not gone, they have not seen the database. Like, if there are opportunities, opportunity products, price books, price book entries, I'm just giving an example, there can be more. So going beyond that is very, very important. You will not be able to design complex solutions until and unless you have a very solid understanding of the data model, including all standard Salesforce objects and data model, plus whatever is built custom, or if there is a data model which is coming from a managed package that you have got, etc. So data modeling is a key thing. So you really need to master the skills of data modeling, understanding the data model, and also being able to design data model for new applications. That is also a very important skill that needs to be built. Another important skill would be understanding the large data volumes, how to deal with the large data volume, what are the options available within Salesforce to deal with large data volumes, etc. This is another very, very important skill that you need to build or develop to be able to become a Salesforce architect, with credibility. Third is integration patterns. Understanding what are the different integration patterns. So I'm actually going to do a complete video on the integration patterns. Now, there are different integration patterns which are recommended or which are part of our Salesforce design. Usually we use one of those. Understanding the integration patterns and understanding which approach would work better for which integration pattern is going to be another very key skill that you would need to have. Next one is asynchronous processing. Now, this is also very important. As I said, there are 2 things here. So one is understanding when to use synchronous versus asynchronous. Very important. Not done properly in many cases. I have seen that a lot of logics. In fact, if I have to talk about my personal observations, most of the projects I see that at least 30 to 40% of your synchronous logics can be moved, on an average I'm saying, can be moved to asynchronous. They do not need to be executed synchronously, but they are written in such a way that they are getting executed synchronously, can be easily moved to asynchronous execution. This is fine, doesn't impact too much if the system is small. Overall, it's not a system which is scaling up, but at an enterprise level system, this will definitely have a lot of impact. So understanding synchronous versus asynchronous, and then also understanding how do you plan your asynchronous processing logics, etc. And last but certainly not the least is the ability to communicate and the leadership skill. So as an architect, there are these, because architect is kind of the owner of the system, right? He owns the system, he is responsible for the system, he is responsible for the entire behavior of the system, performance of the system, etc. So leadership skills, of course, are very important, and communication skills are very, very important. There cannot be an alternate to a good communication skill. No matter how good you are technically, but if you're not able to communicate the value add that you're trying to bring in with the approach that you're proposing, you will not be able to get the buy-ins from the other stakeholders in the system, right? So, and also an architect is someone who kind of acts as a bridge between the business stakeholder team versus the dev team, right? Now, he has dual responsibility. He has to listen to the requirements from the business stakeholder, and then he'll need to pass it on to the team of developers, and he has to listen to the challenges that developers are facing and pass it on to the business stakeholders. So for that also a lot of communication skill is required. So needs to be assertive, needs to be able to communicate his point, needs to be able to, and communication is also not just restricted or confined to the verbal communication. Communication would also mean being able to have those architectural drawings, etc., presentations, doing that system architecture, etc., documentation, so that things can be communicated in a proper way, whether it is one-to-one or in a call, in a meeting, or through means of documentation. So these are some of the key skills to begin with on your journey to becoming a Salesforce architect. I would, as I promised, I am going to make more videos in this series, so stay tuned.